Hey, thank you so much for joining. Sorry for technical difficulties. This is general work with Sina and Uefa. Sina in Alto University and Uefa in Florida. And the question is, can large language models discover novel economic theories? Um, so basically, the intuition is that theory generation, at least in economics, is kind of like informal. So researchers rely on intuition, domain expertise, repeated attempts. But we know from very old literature that creativity is also due to variation and selection. So, generate many ideas, evaluate and retain the best. And creative success is partly a numbers game. So LLMs as variation engines will cheaply generate many diverse candidate theories, recombine existing concepts in potentially novel ways. And if useful theories occur with non-zero probability, then more draws equal more discoveries, right? And then the question is, can we build a general purpose system that discovers novel economic theories automatically? So we call it AutoTheory. And the background briefly is that LLMs can predict stock price movements based on news. They can trade another different paper, and then this paper can they make theory. So theory generation is one of the hardest parts. Yeah. And what we'll do is we're gonna take advantage of empirical puzzles. So in economics and finance, usually you have a set of empirical facts that you want to explain, and you're lacking a formal theoretical model of what can generate that. These models are going to be very specialized, so I'll try my best to explain briefly what's the issue. And then use large language models and evolutionary research to generate candidate theories at scale. Filter with math verification, code generation, and parameter optimization, and simulated peer review. And the output will be ranked theories with closed form solutions, code, and calibrated parameters, right? So it's not going to be the LLM itself, it's going to be the pipeline that combines generation with evaluation. Obviously, there's a lot of AI discovery, so like AlphaFold with protein structures, font search with combinatorics, AlphaFold with algorithmic discovery. I think the key difference is that economics are not really formally verifiable. Like it's not that there's actually a complete way to rank economic theories or finance theories because they're model of humans' behaviors, not physics, so they're always going to be failing. So you're going to be needed to judge not only the numerical fit, but also the parsimony, how well it works, etc. And to produce complete theories, not statistical patterns. So this would be basically the system architecture. So problem analysis, theory evolution, math audit, pseudocode plus review, code translation, calibration agent, parameter optimization, quantitative scoring, referee, and autosave, where most of the stage will be done by LLMs, but there will be a few where Python will be taking over. Yeah. The key idea is just scale. So suppose a large language model can generate a full useful theory with probability P. If you run any dependent draws, then the probability of at least one useful would be 1 minus 1 minus P to the n. So that decays that increases very fast. So even if probability is 1% after 500 independent runs, you get a 99% probability of generating something useful. And of course, parallelization makes large n practical. So you can just, do 128 workers at a time. So that will take you maybe hours, not days. But then not all draws are equal. So the thought experiment is assuming independence, but maybe LLMs tend to repeat similar ideas. So what we need is to sample broadly from the theory space, not just repeat the same region, right? So the solution is going to be evolutionary research, and I'll speak a little bit about how to generate diverse initial ideas. Yeah. So basically, the idea is evolutionary research. So we're going to maintain a population of candidates and iteratively improve of them. So the population are going to be the top models. The selection is going to be the score weighted, variation, mutator or cross, and then evaluation is going to be the pipeline. Yeah, and that's going to lead right to the next generation. And in our setting, individuals are going to be economic theories, and then mutation is going to be modify one mechanism or simplify a parent theory, crossover, combine insights from two parent theories, selection, higher scoring models more likely chosen as parents, and generation steps from first random ancestor Right? And that's going to be balancing the exploration. So random with personas, I'll speak a little bit about. With exploitation, that's maintained refined. Yep. So to get different initial solutions, I'm gonna use what's called persona. So each round, we're gonna get a randomly assigned persona, or often to three, that shapes how the large language model will reason. And we have 20 personas available, and the maximum combination of three, about 20 is something astronomical. So that's gonna be fine. So for example, the persona is going to be like beige and contrarian, like both at the same time. So you must think from all these perspectives simultaneously. You're a Bayesian who thinks in terms of priors, posterior, updating, and evaluating information. And you're a contrarian who looks for assumptions everyone takes for granted but are wrong. Yep. So you can have both personas, and that's going to increase a lot the space of diverse ideas at the beginning, right? So I put a bunch of them: mathematician, game theories, decision theories, etc., and or macroeconomics, microeconomics, behavioral, institutional, network, physicists, contrarian, right? And different personas are going to discover different mechanisms. So this is a super easy trick to get a variety of theories, and this would work in other domains as well, right? Then after the persona sets the lens, the analysis problem would ask, think really hard. This is a genuine research problem that has top economists. Be specific and analytical, avoid big suggestions like add frictions, instead say exactly what kind of friction and how it would affect. So the process is mildly detailed. And then once we have the initial analysis, this is passed to the theory evolver as context. Yeah. The theory evolution would be roughly around 20%, fresh mechanisms from scratch, mutate a successful parent model, combine best elements of two parents, or fix referee identified weaknesses. Yeah. And then the parents, the top 10 weighted by score would be, for example, propose a modification, options in order preferences, simplify, so remove a parameter or combine terms. Right, so you want the same quantitative output, but with fewer parameters, so like trying to improve the theory, or modify a mechanism in that sense, right? And the output would be full proposal with derivation, calibration targets, and economic intuition. Yep. Something that I notice a lot is that these models were making mistakes in the math. So they were taking shortcuts. They were not doing the math correctly. So basically, I added large language models as auditor. By the way, all of the models are going to be GPT OSS 120 billion. So relatively small model, very cheap, very fast, very smart. So what I did was like separate math audit to check the proposer's math using adversarial verification. Just you must verify every equation, blah blah blah. This allows the model like up to 3 audit fixed cycles. So the proposer will revise if the audit fails, and it catches like roughly 40% of proposals with errors. So 40% of proposals, the model wasn't internally consistent, like the math wasn't internally consistent. So it just removes it. Yep. And then for the ones that pass or that are trying to pass, you basically get the comments to see what was wrong. Then I also change well, at first I was trying to generate code directly, but that is a little bit too strict because the model will just be lazy and do something else. So what I did first was first from the proposal you get the structured pseudocode, write just the algorithm description, and then the reviewer will check whether the pseudocode is equal to the proposal. And then stage 3 would be from the pseudocode you get the executable Python code. And then the reviewer will check, is the code equal to the pseudocode? Yep. That basically allows the model to catch any hallucinations. And of course, the prompt would be something like implement the formulas exact as written in the proposal. Do not use any specific numerical values claimed by the proposer, right? Because those would get calibrated later. All parameters should be inputs to the functions and not hard coded. That's just for the Python stuff. And then 3 times 3 nested retries, so 3 fresh starts times 3 fixed attempts, so a 9 total of chances. The code must compile and run without errors, and if it doesn't, it just also never reaches evaluation. Yeah, so it's kind of like you need to pass the math, you need to pass the code in order to make something sensible. Then the calibration agent will read the generated code and determine parameter bounds and default. So it will just infer sensible ranges from economic reasoning. So for example, there's something that's called risk aversion that measures how much people dislike uncertainty, and sensible choices maybe from like 0.5 to like 10. Anything else would not be really reasonable based on economic theory, right? So this will guard against the degenerate regions and search starting points from the optimizer, right? And then the only job of this engine would be for each parameter provide a lower bound and an upper bound and a default, a reasonable starting point. Yeah, this is going to be useful because this is going to bound the search, the space search, and this is going to give the numerical optimization written in Python and fixed forever some reasonable starting points, right? And of course asking JSON as a default. And then the parameter optimization is not LLM-based, it's just pure numerical optimization. So SciPy differential evolution and minimizes the weighted distance to all target moments simultaneously. It's going to be a population-based global optimizer and avoid locals minima in general. And it has like a 5-minute wall clock deadline per run, and basically just minimizing the relative function with importance weights if needed. In practice, most of it is just equally weighted. Yeah. And then if the optimizer cannot find parameters that hit targets within the tolerance level, the model is discarded again. Yep. Because it's not really good quantitative. Finally, some quantitative scoring, no LLM, just deterministic. So the score is going to be 0.6 times the fit, then the plausibility, and then the parsimony, where all of these are just parameter counts or functions of the numerical values. And then the large language model referee would evaluate the full package, so the proposal, plus the code, plus the calibration and the numerical score that it receives, right? And it will judge based on empirical fit, economic plausibility, novelty, and parsimony. Yeah, so this is the major difference with most just pure algorithms that in general, you may not have an actual quantitative score, right? Because it's not only about the empirical fit, it also needs to make economic sense, and then there's not obvious ways to make that automatic. So LLM as a judge really works on this, and then it basically have different scoring guidelines. Yeah. Obviously, the question is like, why do we need such a complicated system? Why not just ask 4.2 Pro to do this? Well, a lot of it's going to be like hallucinations in math errors, and obviously the adversarial math audit would help solve this. Hallucinated calibrations, but in this case, the optimizer actually solves, right? And we have fixed the optimizer, so it cannot be gamed. The LM doesn't know what optimizer is, and different LMs just do different stages. It cannot run its own code, so code as verifier, no error recovery, so this is just multi-stage. Context length limits are, of course, going to be avoided by modular stage. And then the overconfident evaluation is going to be quantitative scoring before the large language model referees. And in order to avoid repeated ideas, the 20 personas potentially combined, plus evolutionary stage. Yep. So this is going to help all of the models, usual caveats. Yeah. So this is going to be an example of the model. You just have to trust me that this makes economic sense. So for example, there's something that's called the stochastic discount factor that would price all the assets. So the market-wide SDF is a well-shared weighted average agent's marginal utility. So maybe theta times CT minus gamma. That would be the usual part. Then LT plus 1 minus theta times 1. And then the price multipliers and the ratio, and the model will explain why it works. Well, the liquidity factor makes marginal utility respond to the idiosyncratic order flow. Consequently, the SDF covariance with epsilon IT, and idiosyncratic risk commands a premium proportional to 5. Yeah. So all of this would look like this. All of the ones that pass are going to be sensible in some sense. Yep. And each of them takes like 6 minutes, roughly speaking, and I'm going to be running like 128 in parallel. Yeah. This is going to be even more abstract for you guys, so sorry. This is for an econ/finance, but basically the puzzle in particular is that there's a price multiplier and how much does $1 net buying push up market cap. If you've been following any of the trading agents,
It's 48
sorry,
degrees, mostly cloudy right now.
Somebody has like their microphone in not anyways. Let me see if I can mute on my side. This is going to get decomposing the order flow into style, correlated buying across a group, so size value groups, and idiosyncratic stock specific. This is important in the trading agent signature because how much you can actually buy or sell depends on how much is your price impact, which is possible. And basically there are two numbers, so like 6, 1.6, and 3.62. And the current models are like orders of magnitude away, so they have something like 14.5 instead of like 3.6. Yep. And I'm not gonna. The challenge for AutoTheory is to find a mechanism that matches all three moments from economic primitives. Yeah, so this is like a constricted space. Yeah, and it's gonna have three target moments. So the SAL, the idiosyncratic, and the ratio. And basically, the best model score is going to be 84 out of 100, right? 22 model scoring 80 plus, 81 model scoring 70 plus. This is a relatively easy score, although the mean score is low. It's like 48.5. Yep. And there's a wide diversity in the sense of a lot of these come from random mutations from scratch, not necessarily from mutate or from crossover, but all the different genetic algorithms are able to discover something meaningful. Yeah. For example, this liquidity adjusted CRA, that's super technical. I know, I'm sorry. It has the persona robust statistician plus monetary economist plus institutional. And the strategy will be random, so from scratch, and the generation force. So it's been like at least 700 previous algorithms tried before reaching this one. And then it would just explain what's going on, the intuition that it is idiosyncratic flow moves aggregate liquidity and price risk, and so on. And on the quantitative side, this model basically nails it. So it has 4 parameters, nails completely the style, the idiosyncratic risk, and the ratio. And the referee liked that it was a micro-founded stochastic discount function from explicit primitives and closed form with 4 parameters. But it has liquidity as linear function or single shock and doesn't like that and thinks segregation is unclear. Yeah. There's a wide range of parameters. So for example, the other one would be game theories, monetary economists, and Bayesian. That would be the persona. Another random one, and it would think that investors observe noisy signals and they have to do a Bayesian posterior, right? And it also nails completely the model with actually 3 parameters. Yeah, so it's a little bit more parsimonious. But the referee didn't like that the mechanisms are individually known and the novelty is only in the combination. And one of the parameters is not directly observable, so it didn't like that. Yep. This would be basically how it looks. So the price multiplier had like 458 runs that run correctly. I tried in theory 500, but some of the LM calls just failed. And this is roughly what the maximum score would look like. So even from the start, it got some pretty high scores because they were fitting the model pretty well. The strategy performance, basically mutation, random crossovers. Crossovers were fewer, only one top 80. Mutation and random were a lot more, and they both have like good scores. Yep. So basically, the search space is multi-model because random can explore distinct peaks that local mutation cannot reach. Yep. And then what drives the referee score? So basically, it's going to be we can add the quantitative fit score, and that's going to add a lot of R squared. So the quantitative fit score, the referee is mostly based on that. The strength, length, weakness, and suggestions is no longer significant after that. Yeah. So the referee is strongly anchored to quantitative fit, but it's not exactly mechanical because if the model doesn't make economic sense, the referee will also catch it and lower the score. Yep. And then dividend strip. So this one is even more abstract, but basically there's an instrument that's called short-term strip. So it just pays you what the stock market is going to pay next year, or you can invest in the whole S&P 500. And in theory, the short-term strip is just a subset of that. So it should be less risky. But in finance, less risky stocks should get like less expected returns and lower Sharpe ratio. In practice, this gets a higher return. So the puzzle is like, why do short-term strips get more mean return on the S&P 500? Yep. And then the leading models cannot basically do this. I'm gonna abstract a little bit, and then AutoTheory It's going to be harder because it will target 10 moments rather than 3 targets, right? So here we'll have the conditional, there will be the term structure slope. That's the shortest higher than long expected returns, the ratio that has to be greater than 1.5, the CAPM alpha and the CAPM beta, and the conditional slope. Yeah, so this is much, much harder in general. So in this case, the theory evolution, I think I ran something like 2,000 out of like which 257 survive. So a lot of them, nothing really gets like that close. So this is a harder problem, and then there's one that proposes an SDF with Bayesian learning, so it's sensible. And the referee likes that the model matches the conditional pattern, but it doesn't like that the closed form is not matching, and then the model presumes expected negative consumption, which is a little bit odd on average. Yep. So the referee is strict, and I would not elaborate a lot on specific form. Yep. So this will be the right mechanisms, right? It actually matches relatively well the target and the Sharpe ratio and the exponential ratio, but it's too many three parameters according to the referee. So it will just, it will get penalized because of that. So the model is not only judging the numerical fit, it's also judging the economic plausibility. And obviously, you know, the question is whether LLMs are making any reasonable economic inference, and the answer is like yes. So for example, the referee would like that this model derives idiosyncratic price of risk from first principle rather than imposing it ad hoc, but it has limited discussion of testable implications beyond calibrated moments and would benefit from predictions for cross-sectional variation under charging short set constraints. And then also, you know, an example of a low one would be calibrated parameters are unrealistic, so gamma equal to 12.7, like a negative factor loading, so that's a lot. And then the penalty does not affect the portfolio weight, so it would score at 12. Yeah. So even though we're using the same model for generating and for scoring, it's not you know, self-congratulatory in the sense that models can get and do get very low scores. Yep. So the referee will identify overparameterization, the realistic calibrations, and demands testable predictions. Yep. And finally, there's a lot of models that, let's say, pass. So the question would be, okay, so which one would we pick? And then what the models would suggest is like they have additional testable predictions that are, of course, not being tested right now, but in principle could be tested, right? So multiple mechanisms will match the same targets, but they generate distinct testable predictions. And then just briefly for the scaling infrastructure, so 128 parallel workers, so each will get like a full 10-stage pipeline. 30-minute hard deadline per run, just to avoid any hanging process, and 6-minute run per average. This would be using GPT OSS 120 billion, so it's like open source. API-based inference, not locally. So, you know, I basically call like something, I think 100 million tokens or something, so it was like $20. It wasn't especially expensive. Yeah, and of course, graceful shutdown in an interruption, incremental service per stage, progress tracking, and optimize deadline enforcement. At some point, I'll make this open source. Yeah. And obviously, there's a big difference between the system by itself that has math errors in 40% of proportional versus the system of LLMs that catches these errors. The hallucinated calibrations by LLMs versus the optimizer finding two parameters. Obviously, LLMs cannot execute or test code, whereas AutoTheory can do code execution as ground truth, no recovery from mistakes versus multi-stage retry, possibly like loops, and then repeating the same ideas over and over versus personas plus evolution will explore more broadly, and then the overconfident self-assessment versus the quantitative scoring and cluster-free. Yep. So the key insight is that no single large language model produces reliable theory, but the system does. Yeah, and basically the models are overconfident, but it's much easier to catch a mistake rather than just not doing any mistakes from scratch. Yeah, and the takeaways are that large language models can discover novel economic theories that explain empirical puzzles with 8 distinct mechanisms from the price multiplier puzzle. And early promising results on the dividend strip puzzle. And the pipeline is innovation, not the large language model. So like, you know, the math audit, the code verification, the optimization, the simulated peer review. And this will filter its creative but prone error LLM output into useful theories. And in principle, AutoTheory is possible agnostic within the realm of economics. And then it's quantifiable it's applicable to any quantifiable possible in economics or finance. Yep. And obviously this is working towards replacing the researchers, so large language models predict, then trade, then theorize, and then obviously the next one would be next automatic empirical testing with arbitrary data set, causal validation, and end-to-end discovery. So that would be all for the presentation.